you will have a moon test on Wednesday. To study for this test, you should make sure that you know the vocabulary which is in your science notebook for investigations 5 and 6, that you study the notes that you have in your science notebook, as well as the classwork that's located in your science notebook that's focused on the moon. This video is also a very good study tool for this test. The moon, like the Earth, revolves around something. The moon, unlike the Earth, does not revolve around the sun. The moon revolves around the Earth, and it does this in a counterclockwise motion. It takes 29.5 days for the moon to complete one revolution around the Earth. The moon also rotates on an axis. It rotates in a counterclockwise motion. The rotation of the moon to go around its axis one time also takes 29.5 days. The moon goes around the Earth in a slightly wonky orbit. Notice that in reality, it's not going in the perfect circle that this diagram would seem to depict. It in fact comes slightly up here and goes somewhat down right through here. This will be important to remember as we talk about the phases of the moon. Part of studying the moon usually involves taking the size of the real moon and making it on a scale that is easy to understand. To do this, we need to go through the process of finding out what scale we want to use. Let's talk next about the phases of the moon. In this diagram, the sun is located on the left-hand side of our screen, and sunlight will be going from left to right. Notice here that half of the moon and half of the Earth are receiving sunlight. Remember that 1/2 of the Earth at a time can receive sunlight. The same applies for the moon. The side of the moon that is facing the sun is the side that will receive the sunlight. Remember how we described the revolution of the moon in a slightly wonky orbit? This is why a moon even way back here is receiving sunlight. It seems like it should be blocked by the Earth, but in reality, this moon is located somewhere down here, still receiving that sunlight. The first day of the moon's cycle is right here. This is day 0. On day 0, the portion of the moon that's getting sunlight is not facing the Earth. The portion of the moon facing the Earth is not getting any sunlight. Therefore, what we see here on Earth is a new moon. As the moon revolves around the Earth, it gets bigger from day 0 to day 14. Day 14 is where the side of the moon that we see is entirely in the sunlight. So we see a full moon. The portion of the moon's revolution from a new moon to a full moon is considered waxing. Waxing means to get larger. In addition to the new moon and the full moon, there are 2 other major events that occur during the cycle of the moon. One of these happens in the waxing period. That is the first quarter moon. The first quarter moon is what some might call a half moon. What we see is half of the moon lit up. Half moon, however, is not the actual name for this phase. The actual name for this phase is first quarter moon, and this happens halfway in between the new moon and the full moon. Also on the waxing side of the moon cycle, we have a crescent moon. Notice here that the portion of the moon that's lit up is only a crescent shape. Because this portion is getting bigger, this crescent is a waxing crescent. Nearer to the full moon, we see what's called a gibbous moon. A gibbous moon is larger than the quarter moon, where we see only half of the moon. Notice here the portion that we see is larger than half of the moon. Therefore, it is a gibbous moon. This gibbous moon is on the part of the cycle of the moon that's getting larger. Therefore, it is a waxing gibbous moon. During the other portion of the moon cycle, what we see is waning. Waning means to get smaller. We know that this must happen because the moon is going from full, where we can see everything, to new, where we can see nothing. Closest to the full moon are the gibbous moons. This moon right here is a gibbous moon. Because it's on the portion of the cycle that's getting smaller, it is a waning gibbous moon. That brings us to our next major event in the moon cycle. We started with a new moon and moved to a first quarter moon and then a full moon. The next major event is considered a last quarter or a third quarter moon. This third quarter moon looks very similar to the first quarter moon. However, notice here that the lighter portion of the moon is on the left in the third quarter, whereas it was on the right in the first quarter. The reason for that is that the moon gets bigger from right to left. Let's take a look back and see that trend again. Right here on our waxing crescent, we see that the lighter portion of the moon is on the right. That portion gets bigger, and here we now have a larger portion of light on the right side. That gets bigger, and now we have a much larger portion of light also on the right. That leads us to our full moon, which is completely light. The moon then begins to get darker and darker. This also happens from right to left. Notice here that the sliver of darkness is on the right, and that becomes a little bit larger for our third quarter and larger still for our waning crescent. Let me point out to you some tricks. The moon always gets lighter from right to left, and it always gets darker from right to left. The crescent moons are located closest to the new moon, while the gibbous moons are located closest to the full moon. These are some things that will help you identify where these phases of the moon occur. The last thing that I want to point out is that this portion that's shaded in on all of these moons, and even on the Earth, they are considered to be having nighttime. That doesn't mean that they will never get light. Keep in mind that, like the Earth, the moon will rotate on its axis. It will just do it very slowly. The surface of the moon is filled with craters. We watched simulations on how these craters were formed. These simulations showed us the formation of simple craters, complex craters, terraced craters, and flooded craters. To watch these simulations, follow these simple steps. First, go to a computer or an app that allows you to use Flash. Safari will not allow you to use Flash on your iPad. After you've gotten to a computer, go to www.fossweb.com. Once there, click Visit as Guest. Then choose Student as your role, South Carolina as where you are, and grade 6 for your grade. Then click Visit. Now scroll down the page to see the books for grades 6 through 8. This will be close to the bottom of the page. Click the Planetary Science book and choose the purple book. This will take you to the simulations for our textbook. Choose Crater Formation on the Moon to rewatch these crater formation simulations.